Alright, here's a video that's going to help you with your Chapter 2 review. The first thing I want to talk about are the three types of equations that you're going to come across, and these are equations for lines. The first one is point-slope form, and point-slope form is pretty nice because it tells you exactly what you need to write the equation of a line, and that is a point on the line and the slope of the line. So when I look at point-slope form, I'm actually just using the point and the slope to write an equation. So what point-slope form looks like is if you got a point x1, y1, and a slope equal to m. Well, point-slope form is very simple. It's just y minus y1 equals m times x minus x1. And it's the easiest form to put an equation in. If you got a point, you got a slope, you put it in that first. From there, you essentially just solve for y, and you get slope-intercept form. So slope-intercept form looks like probably your most familiar, which is y equals mx plus b, where m again is your slope, and b is what we call the y-intercept. It's the point where the graph crosses the y-axis. So that would be your slope-intercept form. And then from there, a problem might ask you to go a little bit further and put an equation in standard or general form. Standard or general form is a form in which x and y are on the same side, and all three coefficients of x, y, and your constant are all integers. So a, b, and c are integers. So integers are all numbers on the number line, essentially like negatives and positives, but whole numbers, non-fractions. Okay? The only time you ever really see equations like this are when you're solving systems, which is why we need to learn it. So let's look at a few of these examples. So starting with, let me just pull this to the front first. Starting with example 2 right here. I'm going to talk about writing the equation of a line and also graphing that line. So number 2, it says find the slope-intercept form of an equation of a line that passes through the given point and has the indicated slope. So they gave me a point, 5, -2, and it's perpendicular to the line y equals 3/2 x plus 2. Well, that's kind of interesting. We haven't talked about that. But if two lines are perpendicular, they have what we call opposite reciprocal slopes. So perpendicular lines have opposite reciprocal slopes. And what that means is you take the opposite, which is if it's positive, it becomes negative, and then you take the reciprocal, which is if it's a fraction 3/2, the reciprocal of that is 2/3. So the slope that I'm going to use is not 3/2, it's -2/3. When you would use the same slope is if the lines were parallel. So I'm going to also write parallel lines. Parallel lines, just clearly two lines that are next to each other, they have the same slope. Clearly when I draw the parallel symbol, it's just two vertical lines, but it essentially means two lines that don't cross. So I got my point, I got my slope. I'm going to start with point-slope form. So it's y minus y1. Well, minus y1 is -2, so it's y plus 2. Slope -2/3 x minus 5. And from there it says write the equation of the line in slope-intercept form. So I'm going to keep going. I'm going to solve this equation for y. So I distribute the 2/3. Y plus 2 equals -2/3 x plus 10/3. And if you need your calculator for this, feel free. I'm not going to use one, but you can to add and subtract fractions. It might make your life a little easier. So I get y plus 2 equals -2/3 x plus 10/3. I'm going to subtract 2 from both sides. So 10/3 minus 2 is essentially 10/3 minus 6/3. So that's going to give me 4/3. So y equals -2/3 x plus 4/3. So my equation is right here. I just have to graph it. So now, getting a little in tighter on the graph, I'm going to graph y equals -2/3 x plus 4/3. So the 4/3 is my b. And the slope is -2/3. So that's all I really need to graph an equation. So I got 4/3 is about 1 1/3. Okay, so I'm going to graph a point right about here. Okay, that might be a little bit closer to 1 1/2, but it's an approximate thing anyways. So now I graph my slope of -2/3. So this is a negative slope. So I'm gonna always rise. I rise all the time. Some teachers might tell you you're gonna go down first. I always go up, and if it's positive, I rise and go right. If it's negative, I rise and go left. Since this one's negative, I'm gonna go up 2, and then I'm gonna go to the left 3. Okay, so there's my other point. I could also go down 2 if you wanted to, and then go to the right 3. Okay, either way, you see that you're going to get a line. Totally missed that line, but you guys get the idea. You got 3 points are going to make that line, and that's number 2 on your sheet there. So you can kind of see, doing number 2, I used both the concepts of point slope form and slope intercept, and also how to graph these things. Okay, the last one I'm going to look at from this page is number 4. All right, so get rid of these arrows just to kind of make it clearer here. And it says find the slope and y-intercept of the equation line and then sketch the graph. So here's an equation that's actually in standard form, and it says find the slope and the y-intercept. The easiest way to do that is to put it into slope-intercept form. So the way you do that, and this is a skill that you're going to use when you do some other problems too, but the way you do that is you solve this equation for y. Okay, so very simply put, if I'm going to do that, I'm going to take and solve it. I'm going to get the 4x on the other side. Okay, I get negative 3y equals negative 4x plus 12. Divide by negative 3, divide by negative 3, divide by negative 3, and then I'm going to get y equals negative 4 divided by negative 3 is positive 4. Negative over a negative is a positive. And then 12 divided by negative 3 is negative 4. So here's my slope-intercept form. Well, m is 4/3, and b is negative 4. So when I look at this answer, that's all I have to do. And it says also graph it. So like we said before, if I know that m is 4/3 and b is negative 4, so all I have to do is just plot the negative 4, the y-intercept, and then 4/3. I'm up 4 over 3. So my equation looks a little bit something like that. Positive slope this time. So I rose 4 and ran 3 to the right. So helped you out with a couple questions on the first page. Hopefully that makes a little bit more sense. Alright, with page 2 of chapter 2 review, there's some general tips that I think are going to help you a lot with being able to complete this page. Okay, the first one is your slope formula. You might already have this. I'm sure you have it in your notes. If you don't, you want to find it in this video. Here it is. The slope of a line given 2 points is y2 minus y1 over x2 minus x1. So the difference in the x's over the difference in the y. So that's your rise over your run. That's the formula. If you're given 2 points, that's how you're going to do it. Alright, domain and range is something that comes up a lot. Domain are all the x values of a function. Another way to think about it is all your inputs. Okay, everything that you can put in into a function is called your domain. The domain can be restricted by 2 things, essentially. Things that you cannot put into a function are negatives under square roots or zeros in the denominator of a fraction. Those are basically the 2 things that you're going to see restricting the domain. For the purposes of these questions in this chapter, the domain is going to pretty much be, for chapter 2, it's pretty much all reals. Okay? The range, on the other hand, are all your y values. Okay? Or all of your outputs of your function. Okay? So all your y values. For this particular one, chapter 2, you're going to have to think about it. Typically, your range is going to be y is greater than something, or y is less than, or equal to something. For these particular questions in this particular section, for the absolute value anyways, you're going to have a range that's restricted, because absolute value graphs look like V's, so there's not an infinite number of y values. There's only a certain number. We're going to look at that in a second. And the last tip I'm going to give you is the idea between parallel and perpendicular. Okay, parallel lines have what we call the same slope. So we talked about this a little bit on the last page. Parallel lines have the same slope. Perpendicular have opposite reciprocal slopes. So 2 things you got to look out for. As far as this page is concerned, I mean, just knowing these tips, I think you're going to be able to do most of the page. I'm going to take a second or two to look at 5 and 6, or actually 5A and B, just to kind of look at how those graphs kind of work and the vertex and domain and range and things like that. So let's take a look at those. If I could pull this behind everything and look at these a little bit more closely. So number 5A gives you an equation. It's an inequality rather. So you know there's going to be some shading involved. Before you can even do this inequality though, you have to make sure that you get the equation in slope-intercept form, because I can't really graph anything unless it's in slope-intercept form. So easiest way to do that is get the x on the other side. So I get 4y is greater than or equal to negative 3x minus 16. All right, at this point I'm divided by 4. I get y is greater than or equal to negative 3/4 x minus 4. Alright, so now you're looking at this, you're like, okay, this isn't an equation, but it actually is graphed essentially in the same manner. The only thing I had to remember is 2 questions, okay? 2 things you have to determine. Number 1 is the line dotted or solid? Okay? And we'll talk about why that is, but basically if it's a greater than or equal to, the line is going to be solid because it includes the graph. If it's a greater than or just less than, no equal to, then it's dotted because the graph is not included. This one's greater than or equal to, so it's going to be a solid line. It's one of those concepts that most students usually get. So if that's something that's troublesome to you, ask your teacher and have them explain a little bit more closely as far as that's concerned. So that's the equation for that one. I know it's going to be a solid line, so I'm going to graph it just like I would graph any equation. So it's negative 4. Alright, negative 3/4. So I rise 3 and I run 4 to the left. Okay, we said it's going to be a solid line. And the last question after that, after I say solid or dotted, is where do I shade? Okay, do I shade above or below? Because it's an absolute value, or not an absolute value, it's an inequality, which means I have to shade either above the line or below the line. In this case, I pretty much just look at it and say, well, y is greater. So the equation y, the y values, the vertical values are greater. So usually that means I'm going to shade above it. The other thing you can do is test a point. The easiest point to test is 0. So what that looks like is if I test 0, I plug 0 in. 0 in for y, 0 in for x. And I see if that's true. Is 0 greater than or equal to negative 4? If the answer is yes, then 0, that point is on the side that you shade. So for this particular equation, I could go by just saying like y is greater, so I'm going to shade up. Or in this case, 0, 0 is a solution, so therefore 0, 0 is on the shaded side. So that's going to be how you graph an inequality. The other one I want to look at was number 5b, and that's an absolute value equation. In this one, we treat it as if it's kind of like it's not really a line anymore. I don't really do slope-intercept form. I'm not thinking like that. I think in terms of vertex and slope. Okay, absolute value graphs have a distinct shape. Absolute value graphs, if you know anything about them, they look like V's. So absolute value graphs kind of have a V shape. Okay, how you change the equation changes the V, or where it is and how steep it is and whatnot. So the vertex of my absolute value graph is found by taking the opposite of what's inside and exactly what's outside. So in this case, x minus 2 inside gives me an x coordinate of 2, minus 5, y coordinate of negative 5. So I start my graph at 2, negative 5, my vertex. From there, I look at the number in front of the absolute value bars, and I say that's the slope on either side. Okay, so the slope on either side, if that number is positive, the V faces up. If that number is negative, the V faces down. If that number is 1, my slope on either side of the vertex is 1 and negative 1. If my slope, if that number is 2, the slope is 2 and negative 2. This one's just 1. There's nothing there, so it's 1. So on either side, since it's going up, I count slope of 1 on one side and then a slope of negative 1 on the other side. And I get a pretty accurate graph of my absolute value. This is a real quick tutorial on how to graph absolute value, and it involves the vertex. So once again, did a couple questions on here for you. But try the other ones using slope formula, using the idea that parallel lines have the same slope, perpendicular lines have opposite reciprocal slopes, and you should have some success with this page. So, on page 3 of your Chapter 2 review, I'm just going to do a couple examples that'll hopefully kind of get you started with some of these problems, because I think some of these are a little bit tricky, and I think just getting them off the ground is probably the hardest part. So looking at the first one, when you're trying to determine if two lines are parallel, perpendicular, or neither, okay, just for reference, most lines in reality are neither. Okay, to have lines relate in a way that they are parallel or that they are perpendicular is kind of special. So what I have to do to determine this is to put each equation in slope-intercept form and determine their slopes. Like we said, slopes of parallel lines are the same. Slopes of perpendicular lines are opposite reciprocals. So number 11, looking at it, I'm gonna solve both equations for y. If the m value, the slope of both lines, is the same, I'm talking about parallel lines. If it's opposite reciprocal, I'm talking about perpendicular. So solving this one, I got subtract 2x from both sides. Solve one equation at a time. I get 5y equals negative 2x minus 16. Divide by 5. And if you're good, you can already see what the slope's going to be, but I'll just keep going. But it's going to be negative 2/5. Okay? This other part, it's not really even important. I don't even care about it. It has nothing to do with this particular problem. The part that I want is right here. Okay? The negative 2/5. I'm going to do the exact same thing for the other equation. So again, I'm going to solve for y. So I'm going to subtract 5x. 2y equals negative 5x minus 16. I'm going to divide by 2. And I could already see what the slope is going to be, but I'm going to continue going. It's negative 5 halves x minus 16 halves, which is 8. But once again, I don't care about that. I'm more concerned with the fact that the slope is negative 5 halves. So I got negative 2/5 compared to negative 5 halves. First indication is a lot of students are going to say, oh, it's perpendicular. No, they're not. Okay, for perpendicular lines to be lines to be perpendicular, the slopes have to be opposite reciprocals. These two things are definitely not opposites. They both have slopes that are negative. Okay, if they were going to be perpendicular, they'd have to have opposite slopes. So when I answer this question, because they're close, they're reciprocal, but they're not opposite. So this one is neither. Okay, like I said, most lines in reality are going to be neither parallel nor perpendicular. Get you started with number 12. Essentially what this question is asking you, it's going to ask you the rate of change. The rate of change is nothing more than the slope. Okay, what is the slope of a line between these 2 points? So it says your salary is $28,500 in 1998, $32,900 in 2000. Assuming your salary follows a linear growth pattern, determine the rate of change in salary per year and determine when your salary or what your salary would be in 2011. Okay, and then what year would your salary be? $52,700. So what you do here is I kind of just make the years my x value and the amount my y value. So what I essentially have to figure out here, and I'm just going to get you started, but what is the equation of a line through 2 points? The first point being 1998, 28,500, and the second point being 2000, 32,900. Okay, so I'm going to find the equation through these points. Okay, if that's troubling to you, then ask your teacher. But essentially, at this point, you use your slope formula, which you saw on the last page. Find the slope. You got a point. You got a slope. Put it in point-slope form. You got an equation. Okay, and then from there, plug in 2011. Right. See what you get from there, and then plug that in for x. From there, plug this in for y and solve for x, and see what year you would have a salary of $52,700. So it's really not too crazy of a question, but like I said, if you have more questions after that little bit of trying to get you started, please feel free to ask your teacher. The last one I'm going to help you with is 13. Okay, a lot of times these questions, although simple, give students tons of trouble. So both questions ask you to write linear equations and slope-intercept form to represent the situation. So it says Samuel owes $700 and is paying back $50 a month. So I'm going to make an equation, and basically, what do you want your equation to represent? So what do you want it to represent? And basically, I want it to represent the amount that Sam still owes. So he owes $700, and that amount of $700, is it growing or is it falling each month? Since it's falling, since you're taking $50 away from that amount that he owes, he's paying $50 off. So after 1 month, he's going to owe $650. After 2 months, he's going to owe $600. He's cutting $50 each time. You're going to subtract your 50. So again, A would be the amount owed. All right, and then M would be the number of months, okay, that he's paid it off. Okay, so A again, amount owed. M is the number of months. Okay, part B, it says $175,000 home increases at $5,500 a year. All right, so like I'm gonna say V. V is gonna be the value of the home. Okay. So the value of the home starts at 175,000, and is it increasing or is it decreasing? And if you say it's that amount is decreasing, then you're not reading the problem correctly, because it says it increases. So you're going to add the amount that it increases per year. Okay, so it's going to be 5,500. And we'll just call the years X. So X is the number of years. Okay, so this is an equation. If I was to say, like, how much is the house worth after 10 years, you would say I would plug 10 in for X and get a value. Okay, same thing with number 13A. If I was to ask you how much does Sam owe after 3 months, you'd plug 3 in for for M, and you'd see how much is still owed. So just kind of think about what the equation represents and think about how you can possibly use it to find the answer. So I hope this helps.